Today I'll be discussing trial paper 2, chemistry 2024. Okay. Right, question number 1. So this question number 1 is your form 4 chapter 2. Right. Baca 1 menunjukkan kita air yang melibatkan perubahan keadaan jirim. Okay, we have two processes here. Process T, process U. Okay, process T, hold on. Process T is basically liquid to gas, correct? Process U is gas to liquid. Alright, just like this first. Okay, we'll look into the questions first. Okay, berikan maksud jirim. So jirim is something that occupies space and has mass lah. Right, sesuatu yang mempunyai jisim dan memenuhi ruang. These are your keywords dan 1 mark. Very easy, very simple. Okay, next. Nyatakan nama proses T dan nyatakan sama ada tenaga haba diserap atau dibebaskan. Now, liquid to gas is penyejatan, correct? Okay. So when liquid, let me just draw here so that you can easy to visualize. Okay. Now, penyejatan, alright, liquid to gas. Okay. As you can see here, tenaga for liquid to turn into gas, to change into gas, we need tenaga haba. Tenaga haba akan diserap. Why? Because this heat will help to break the force between the zarah-zarah, between the particles. Right? It will help to break the bonds, the forces between the particles. And for that, we need heat. Jadi, tenaga haba akan diserap. Okay, penyejatan, tenaga haba diserap. 2 marks there. Then, next. Lengkapkan kotak berikut dengan melukiskan susunan zarah bagi menunjukkan perubahan ketika proses U. Proses U is gas to liquid. So gas, okay, to liquid. For this type of question, number 1, make sure the size of the particles are the same. Alright. Second, ensure that you fill in the whole box. Right? If this is the given box, they will draw a box inside there and then they'll draw the particles wrong. Okay? If this is your box given correct, fill up the whole box. Okay? So, bear these two in mind. So, yeah, we have gas here, correct, liquid. Okay. 2 marks there. So, easy 2 marks. Question number 2. Right? Okay. Question number 2 is Form 4 as well. Form 4, Chapter 2. Ajar 2 menunjukkan contoh bahan kaca dan seramik masing-masing yang digunakan dalam kehidupan seharian. Nyatakan komponen utama bagi kaca. Simple. To make up kaca, your bahan asas for kaca is silica. Okay? So, yes, silica, 1 mark. Next. Nyatakan jenis kaca yang digunakan dalam rajah 2. Berikan satu sebab. Okay. So, jenis kaca, there are 4 types. Okay. 4 types of kaca. First one is kaca silika terlaku. Kaca silika terlaku. Second one is kaca soda kapur. Okay. Third one is kaca borosilikat. Fourth one is kaca pelambam. Okay. So, kaca silika terlaku is usually used for like telescopes and stuff like that. Kaca pelambam is usually for your chandelier. Why? Because the index BSN is very high. Okay. Kaca soda kapur, on the other hand, is usually, you use this to make glass Tupperware, glass water bottles and all. Kaca borosilicate is usually used to make your alat dan juga radas in your the laboratory equipments, your beaker, your tabung uji, it's all made using kaca. Your kelalang cone is made using kaca borosilicate. So in this case, nyatakan jenis kaca yang digunakan dalam rajah 2. Okay. So rajah 2 here, okay, you look at this, there's so much of heat, directed towards this pot. That means the kaca that you're about to choose must, it must tahan haba yang tinggi. It must be able to stand high amount of temperature, correct? So in that case, kaca borosilicate is the best. Okay, is the best. Why? Because kaca borosilicate boleh tahan suhu tinggi and its pekali pengembangan adalah rendah. Okay, pekali pengembangan adalah rendah. So, kaca borosilicate pekali pengembangan rendah and it can also tahan terhadap suhu tinggi or sifat rintangan terhadap haba. Okay. 1 mark there, 1 mark there. Then 2 marks. Next. Berikan satu contoh sebatian yang membentuk seramik. Berikan only one satu contoh sebatian yang membentuk seramik. So ceramic is basically made out of what? Tanah liat. The main component of it is basically tanah liat seperti kaolin. Okay? Alright, simple. You see, Form 4 chapter 8, chapter 8. Form 4 chapter 8 is basically a chapter where it requires you to hafal several things. Like the composition of each kaca, the functions of each kaca, ceramic, what is it made of. There are several things for you to memorize. Unless if you do a lot of question and you macam terhafal, teringat, then that's a different story. But for that, you have to do a lot of latihan. But, if let's say you don't have that much of time with you, then you have to actually memorize it. It requires you to memorize several things. If not, you cannot answer. Okay. Nyatakan satu perbezaan sifat asas kaca dan ceramic. Like in this case, kaca is see-through, ceramic you can't see through. Right? See, kaca looks in, you can see the water inside here, correct? No, you can see the water. Here, even if you add water, you can't see. So, kaca looks in, tetapi ceramic legap. Or anything else that makes sense lah. Alright? Is acceptable. This is an open answer. It has many answers. Okay. Yeah, right. Question number 3. Okay. Rajah 3 menunjukkan pipe air yang diperbuat daripada sejenis polimer. Nyatakan nama monomer bagi polimer itu. So, we already give the name of the polymer lah. Polychloroethanol. So, the monomer is chloroethanol. Okay. Easy 1 mark there. Apakah jenis tindak balas pempolimeran bagi pembuatan polychloroethanol? It is pempolimeran penambahan. Okay. During pempolimeran penambahan, what happens is that the ikatan covalent ganda 2 between the carbon atoms will basically terputus ataupun dibuka. Where what happens is that it will open up to it will open up to somewhat like this, and then another monomer will come and add, so it will become a continuous chain. That's how you create polymer through the process pempolimeran penambahan. Okay. Next, tuliskan persamaan pempolimeran bagi chloroethanol. Okay, so here as I said earlier, you see this ikatan kovalent ganda 2 dibuka basically, and your N represents how many ulangan it does. Okay, so we don't know, so we just represent it as N. So 2 marks there. Okay, apakah sifat-sifat polimer tersebut yang menjadikannya sesuai digunakan sebagai pipe. So definitely it must be keras, it must not berkarat, or it must be kuat, tidak mudah terkakis. Okay, all these things are hold on. Okay, they all are acceptable. Any 2 answers lah. So it's only 2 marks here, right? Done. Okay. Next question number 4. Raja 4 menunjukkan sebahagian jadual berkala unsur. Okay. Huruf-huruf yang digunakan tidak mewakili simbol unsur yang sebenar. Berdasarkan Raja 4, nyatakan unsur yang wujud sebagai gas monoatom. Okay. When you get these type of questions, before that, this is Form 4, Chapter 4. Okay. When you get these type of questions, it is advisable for you to know what element it is. You definitely can know what element it is because you've been given periodic table. So you can know what element it is. It is lah. Why? Because it'll be easier for you. Even if you get stuck at one point, if you know what the symbol, that symbol represents, what element it represents, it'll be very much helpful for you, right? So now let me write this, the unsur, the actual element of it. Okay, so your H is lithium, your J is natrium, it's sodium in English. Your M here is neon. Your L is chlorine. Your K is sulfur. Trust me, if you know the actual element, it'll be way easier. Okay. Nyatakan unsur yang wujud sebagai gas monoatom. So gas monoatom is also known as gas Adi, which is under kumpulan 18. So kumpulan 18 consists of all inert gases, lengai secara kimia. And okay, 1 mark. Okay, next question. Tuliskan simbol X bagi unsur yang membentuk oksida amphoteric. Okay, what is oksida amphoteric first? Oksida amphoteric, it can function as acid and base as well. Okay, where else oxida acid can only function as acid, oxida base only as a base lah. Okay, so oxida amphoteric in your color 3 is basically aluminium. It's here lah, aluminium is placed here. So you just write an X here, 1 mark. Where else here, your natrium as well as your magnesium will be oxida base. Your silicon here, phosphorus, sulfur and chlorine will become oxida acid. Alright? Okay. So basically, if let's say you larut natrium oxida or magnesium oxida in water, it will form a larutan beralkali, an alkaline solution. If let's say you mix either sulfur oxida or chlorine oxida, it will form larutan what? Larutan beracid lah. Larutan beracid. Okay. Yeah, that's about it. Okay. Alright. So yeah, oxida amphoteric on the other hand it can react with either, since it's both acid and base, it can react with either acid or base to form garam. That means oxidoamphoteric plus acid or base, either one of it, it can form garam plus air. Oxidoamphoteric, okay, can bertindak balas dengan kedua-dua acid dan base to form garam dan air. Okay, simple, very simple basically. Right, next, susun unsur dalam skala 3 daripada saiz atom paling kecil kepada saiz atom paling besar. Okay. Now, okay, let me just erase a few stuffs here. So that I'll have enough space to draw and show you guys. Okay. Now, this is your color 3, correct? This is your color 3. So as you move left to right, the basic difference is that the bilangan proton and the bilangan electron bertambah. Agree with me? Okay, example. Natrium, which is sodium, consists of 11 electrons, 11 protons. Atom natrium, okay? What else? Chlorine consists of 17 protons, 17 electrons, correct? Okay. Now, as I said earlier, it's proven already lah that when you move from left to right in color 3, in period 3, your proton number as well as your electron number increases. Correct? Okay, simple. So let me just write it down here. Bilangan proton plus electron bertambah. Okay. So when your bilangan proton dan elektron bertambah, the charge, berlaku pertambahan charge dalam nukleus, correct? Correct or not? Because when, as your proton number is increasing, right, your nucleus now will become more charged and, it will become more charged. So you're basically now, the nucleus for chlorine is way more charged compared to your nucleus of your atom, compared to your nucleus of the natrium, atom natrium, correct? Right. When your proton increases, the charge in the nucleus also increases. Neutron in this case doesn't play a big difference because it is neutral, correct? Yes. So, pertambahan charge berlaku dalam nucleus. So, when your nucleus is more charged, what happens is that daya tarikan nucleus terhadap elektron bertambah. Correct or not? See, let me draw it here for you. Easier to visualize. Okay. I mean, it's just a sketch, okay? So, it's not up to the mark. It's just for you to, easier for you to imagine, okay? Right, so this is your natrium and this is your chlorine. Okay. So, since the nucleus, the nucleus of the atom chlorine is way more charged compared to the natrium's one, So the daya tarikan nucleus terhadap electron will be more stronger. The force will be more stronger compared to this. Sorry, hold on a second. Let me just draw the electron here. See. Okay, right? Okay, so if the force is, getting stronger and stronger, what happens is that this force will eventually pull the electrons towards the nucleus. It will pull the electron towards the nucleus, making the whole size of the atom smaller. Alright? Logical enough? Easy to understand, right? Okay. So that is why when you move from left to right in period 3, the size of the elements reduces. The size of the atom reduces. Okay. Now, going back to the question. Susun unsur dalam skala 3 daripada saiz atom paling kecil to paling besar. So, L paling kecil diikuti K, X, J. But if let's say you never write X, also can. Alright? If you write X, also can. Because X is an answer to a question. Okay? But better for you to write X. Okay. Next. Bandingkan kereaktifan unsur H dan J apabila bertindak balas dengan oksigen. Where is H and J? Okay. H and J is here. Okay, this one also eventually I have to draw and show. It's easier to understand. I hope you understand on the size for period 3. Just hold on a minute. Let me erase all this. Okay. Alright. So unsur H and J, right? Okay. Now, lithium has 3 electrons, correct? Whereas natrium, which is sodium, has 11. Okay, let me just draw it here for you. Again, it's not up to scale. This is your lithium. Natrium. Okay, it's not up to scale. Okay. When you go down the group, when you go down group 1, as you can see here, the bilangan petala semakin bertambah, correct? Lithium has only 2 petala, natrium has 3 petala, correct? So bilangan petala bertambah. When bilangan petala bertambah, alright, the distance between the nucleus and the electrons, especially the electron valence, increases, correct? You look at the distance here and the distance here. Can you see the difference? Jarak antara nucleus dengan electron valence for your natrium, sodium is way jauh berbanding lithium. Okay? So your jarak, jarak antara nucleus terhadap electron valence especially lebih jauh, correct? It increases. So when the distance increases, the force reduces. Correct or not? Daya tarikan nukleus terhadap electron valence berkurang. The force the force decreases. So when the force decreases, daya tarikan tu berkurang, what happens is that electron valence is, especially at the end here, electron valence is not hold on tightly into its orbit, right? Sebab daya tarikan dia semakin lemah, so it is difficult for atom medium to hold this electron valence. Correct? Alright, in that case, when it is difficult for it to hold on, it will be easier to let go. Sebab susah, because of weak force, it is difficult to hold that electron, which makes that electron easy to escape. It escapes easily. So that is why the reactivity increases. Okay, as you go down group 1. There we go. Unsur J lebih reaktif berbanding unsur H. Okay, 1 mark there. For bandingan question, if let's say there is perbezaan bandingkan, the keywords are basically berbanding, daripada, and or lebih. If let's say you want to bandingkan two things, right? A lebih kecil daripada B, A lebih tinggi, there must be the word lebih to show that one is higher or lower than the other one. Okay, lebih reaktif berbanding unsur H. Okay, 1 mark. Jelaskan jawapan anda. Alright, for this 4D. Okay, so I already explained it here for you. You just have to write it in the form of sentences lah. Jejari atom J lebih besar berbanding jejari atom H, which is the jarak. Okay, sorry, the radius. Okay, jarak antara nukleus dengan elektron valence dalam atom J lebih jauh berbanding atom H. Alright, 1 mark there. Daya tarikan nukleus terhadap elektron valence dalam atom J lebih lemah berbanding atom H. Okay, jadi atom J lebih mudah melepaskan elektron berbanding atom H. This is a complete sentence, complete answer, solid 3 marks. Alright, another tip is that when you are writing your answers, make sure your answers are clean and clear. Make sure, like in this case, like it is very much clear and it is understandable, right? And another thing is that make sure pemeriksa cannot question back your answer. Make sure it's that clear lah, right? Okay. Alright, so yes, that's about it for question 4.